Okay, this is our lesson. It's an extension 1 lesson on the angle between two lines. Now, the acute angle between two straight lines is given by this formula. Tan theta equals the absolute value of m1 minus m2 over 1 plus m1 times m2, where m1 and m2 are the gradients of the lines. Now, if you look at this formula, I know we've got tan theta over this side, but theta is the angle between the two lines. If you look at the right-hand side of this equation, this m1 minus m2 over 1 plus m1 m2, you will recognize it as being very similar to the sums and differences of angles. It's actually the difference between tan, for example, alpha minus beta. You'll recognize it as that as we go on a little bit further. I'm now going to prove this rule. Okay, now I've got my y-axis here, my x-axis there. I've got line 2 there and line 1 there. Now, I'm going to call this up here point A. This one down here is point B. And here I've got point C. Now, remembering with gradient, you know, is y equals mx plus b if you know the equation of the straight line. But if you don't know the equation of the line and you actually know the angle between the positive x-axis and the line, so for example, if this angle in here is alpha, then the gradient of line L2 would be M2, I'm going to call that M2 is tan alpha. So for line L2, the gradient, so gradient of line, so I'll just write gradient of line L2, sorry, I'll just move this screen down here, okay? So I've got the gradient of line L2, which I'm going to call M2, in other words, gradient of line 2, M2 is tan alpha. Then I can also look at the gradient of this line L1, so if the angle between the positive x-axis and the line L1 is beta, then I can say that the gradient of line L1, I'll call it M1, happens to be tan of beta. Okay, now we can, I'm also going to let this angle up here be theta, this angle between the two lines. So if you look back up at the formula up here, okay, the angle between two lines, tan theta, if you look at my diagram here, theta is the angle between my two lines. But tan alpha is the gradient of line L2 and tan beta is the gradient of line L1, remembering the formula that the gradient of a line, so the formula for gradient of a line is m equals tan theta, where theta is the angle that the line makes with the positive direction, of the x-axis. So actually I'll just move this down here. So I'm just straightening up my thing. Okay, so m equals tan theta, you would have learned that last year in year 10. So that gives you the gradient of a line as well. So we're going to continue on with this proof. So if theta is the angle between line L1 and L2, we can see that here beta is the exterior angle of triangle ABC. So I can say that beta, this angle out here, beta equals alpha plus theta because it's the exterior angle of triangle ABC. So I can say therefore theta, I'll just move this down a bit, and so theta is equal to beta minus alpha. Now, what we're going to do now is I'm going to take tan of both sides. So therefore tan theta equals tan of beta minus alpha. Now, we will now use our sums and differences of angles to work this out, okay? So we know that tan of beta minus alpha is tan beta minus tan alpha over 1 plus tan beta times tan alpha. Now going back to our definition of what tan beta and tan alpha are up here, we know that tan beta is M1 and we know that tan alpha is m2, so we've got tan of theta is m1 minus m2 over 1 plus tan beta again is m1 times tan alpha is m2. So therefore that's our formula there for tan of theta. Now, if tan theta is positive, then theta is acute. Okay? And if tan theta is negative, then theta is obtuse. This is because, for example, let's say the angle between the two lines is less than 90. Let's say the angle between the two lines is 60 degrees. I'll just go back up to my diagram up here. So if the angle between the two lines, we'll just go back to our formula as well, okay? Now, if this angle here between the two lines is, say, 60 degrees, then tan of 60 will be root 3, for example, and you'll get a positive answer for this m1 minus m2 over 1 plus m1 times m2. But if this theta in here is bigger than 90, and let's say we're doing tan of 120 or something like that, let's say it's 120 degrees, then tan of 120 is negative. So this m1 minus m2 over 1 plus m1 times m2 will give you a negative answer. Now the formula actually has these absolute value signs, and the reason is that this formula will actually give you the acute angle between the two straight lines. So it won't give, so let's say this angle here is obtuse. What it will do, it'll actually give you this angle over here, the acute angle between the two lines. So if you were getting 120 as your angle here, it'll give you the 60 degree angle there. You probably don't understand what I mean there at the moment, but when I go through some examples a bit later, then you'll understand. All right, I'm going to move back down to the page. So again, if tan theta is positive, then theta will be acute, and if tan theta is negative, then theta is obtuse, and that's got to do with all stations to central, because tan is positive in quadrant 1, but tan is negative in quadrant 2. And so therefore, if you want the acute angle, so for the acute angle between two lines, we will need to take the absolute value. So we go tan theta is the absolute value of m1 minus m2 over 1 plus m1 times m2, absolute value sign. Now, remember I said if you look at this, it sort of looks like the sums and differences of angles. Now, if we look back up here, tan of beta minus alpha is tan beta minus tan alpha over 1 plus tan beta times tan alpha. And this m1 and m2 just represent the two gradients. So therefore, this m1 minus m2 over 1 plus m1 times m2 is actually just the differences formula for tan, the difference between two angles, and you're doing tan difference between two angles. So that's what this formula is based on. Okay, I'm just going to pause the video and we're going to do some examples of this now. Okay, this is our first example. It's actually question 1J from exercise 7.9 of your textbook. Okay, and the question is to find the acute angle between the lines x minus 2y minus 3 equals 0 and 6x minus 3y plus 4 equals 0. Okay, let's start with this first line here. We've got x minus 2y minus 3 equals 0. I'm going to take the 2y to the other side, and I'm going to get x minus 3 equals 2y. Now, if I divide everything by 2, I get y equals x over 2 minus 3 over 2. Therefore, the gradient of this line is a half, remembering it's the coefficient of the x when your equation is in the form y equals mx plus b. Okay, let's look at the second line. So we've got 6x minus 3y plus 4 equals 0. Let's take this 3y over to the other side. We get 6x plus 4 equals 3y. And now we're going to divide everything here by 3. So we get y equals 6 over 3x plus 4 over 3. In other words, that y is equal to 2x plus 4 on 3. Therefore, the gradient of line 2 is 2. So now we've got our two gradients, and we can use the formula for the angle between two lines. Now, the angle between two lines formula is tan theta equals absolute value of m1 minus m2 over 1 plus m1 times m2, which is absolute value of a half minus this 2 here over 1 plus a half times 2, which gives us tan theta is a half minus 2 is negative 1.5 over 1 plus 2 times a half. Now a half of 2 is 1, so 1 plus 1 is 2. So just coming over here, we get that tan theta is, we've got negative 1.5 over 2, and you can do that on your calculator if you want. So 1.5 divided by 2, and we get 0.75. So we get tan theta is negative 0.75. Remembering we're taking the absolute value of that, which is positive 0.75. Now notice we're getting a negative value in there. If we don't take the absolute value, we're going to end up with the obtuse angle, but we want the acute angle between the two lines. So tan theta is 0.75 once you've taken the absolute value, and to work out theta is just tan to the minus 1 of 0.75, and I'll just do that now. Shift tan of 0.75, make sure you're in degrees mode, and you should get 36 degrees 52 minutes. So that's our first example. Now we're going to try an example from the next question. Now for our next example, I'll call it example 2. It is actually question 2D from exercise 7.9. I'll just let that focus first, won't be a minute. Okay, and here is the next example, question 2D. Find the obtuse angle between the lines 5x plus 2y plus 1 equals 0 and 4x plus 7 minus y equals 0. First thing, let's work out the gradient of each line. So let's put them all both into y equals mx plus b form. So we've got 2y equals negative 5x minus 1, which means that y is minus 5x on 2 minus a half. So therefore, gradient 1 is negative 5 on 2. Now with our second line, putting it into y equals mx plus b form, we've got y equals negative 4x plus 7. That's already in y equals mx plus b form, therefore gradient 2 is negative 4. Now we use our formula, tan theta equals absolute value of m1 minus m2 over 1 plus m1 times m2. Substituting in those values, sorry, I've just gone out of focus, I'll just fix that up. Okay, entering in those gradients, m1 is negative 5 on 2, which is negative 2.5. So I'll put that in. So it's negative 2.5 minus m2 is negative 4 over 1 plus negative 2.5 times negative 4. You can work that out. Negative 2.5 minus negative 4 is negative 2.5 plus 4, which is positive 1.5, and that is over 1 plus, well, you've got a negative times a negative is a positive, so it'll be 1 plus 2.5 times 4 is 10. 1 plus 10 is 11. So, 1 minute. And so taking the absolute value of that, tan theta is 1.5 over 11. And to work out the angle, theta is tan to the minus 1 of 1.5 over 11, and you can work that out on your calculator, and I'll just do that now. And if you do that, tan to the minus 1 of 1.5 over 11, you'll get theta is 7 degrees 46 minutes. Now remembering this is the acute angle between the lines, between the two lines, therefore the obtuse angle will be 180 minus 7 degrees 46 minutes, which is, I'll just work that out, and the answer you will get is 172 degrees and 14 minutes. So that's the obtuse angle between the two lines. Okay, that's the end of the first video. You can stop this now, and we'll watch the second video with a few more examples.